Hello everyone, my name is Alysha Wahdiah Binti Abdullah. Today I'm going to talk about introduction of this project. First, drying process is one of the methods that have been used in order to preserve the fruit and vegetable from spoiling after harvest. Next point, the moisture content of every product will reduce until there is no space for bacteria, yeast, and mold to grow on the products. Here, the disadvantages of open sun drying. First, require large surface areas. Next, long time taken to dry the products or crop. The third one, the product or crop will damaged by the weather conditions such as rain and heavy wind. The last one, insects, mold, yeast, enzymes, bacteria and animal attacks can damage the whole products or crop. So this is the solution to overcome problems from open sun drying. Sun plus air, we will produce solar dryer. Here, advantages of using solar dryer system. For the first one, the drying process is faster due to temperature difference, which is inside the dryer is warmer than the outside. Second one, lower chance of spoilage due to the speed of fruit and vegetable being dry. The third one, the quality of the fruit and vegetable being dry through solar dryer method is better in terms of nutrients, hygiene and color. So, 1,500 gram tomatoes have been chosen as the study of the design for this solar dryer system.
Our team main objective is to design and fabricate the soil drying system for tomatoes. The second objective is to analyze the soil drying system for tomatoes using ANSYS software.
Hi, my name is Aizuddin Azri and I will explain on how the system will work. Okay, so how the air will flow. So we will located a fan at both of the inlet, and the fan will draw in the air from the outside to goes inside the solar collector and then goes throughout the whole heating chamber and then goes out of the chimney. Also, there will be some of the air will goes through inside the regeneration tube to goes back into the solar collector. So from this picture, we can see how cool air is drawn in from the inlet and then becoming a warmer air by using the solar collector, and then hot air is the finished product of the solar collector will be flow in through the chamber to dry all the crops inside and then goes out, but some of the hot air will be generated back inside to the inlet and then goes in as a warmer air here. So it will have a warmer air in a shorter time. So what is regeneration air? So we take this Brayton concept from thermodynamics, where all the air from the compressor will be reheated back by the hot air that goes from the combustion to turbine, and then the air from the compressor is heated by the air, so it become a preheated air before it goes to combustion, so it take lesser energy to combust the air. So by using the same Brayton cycle, we will have the air that goes to the chimney, some of the air that goes to the chimney to the inlet of the solar collector, so it have a warmer air to start with. According to Ahmed, who has done the same research, which is regeneration in solar drying, he said that the thermal drying parameters have been improved thanks to the regeneration process, because the heat of the humid air which is normally released into the environment is now used to preheat the air entering the solar collector. So it will decrease the amount of heat required to dry the crops inside the heating chamber. So this shows how the velocity will flow inside the heating chamber. It goes from the inlet throughout the whole system and then goes to the chimney. So the volume rendering also shows how the air is distributed fairly to every tray so that all the crops can be dried in the same amount of heat altogether. So this shows how the temperature from the inlet throughout the whole system until the chimney will have a equal distribution of temperature, so all the crops can be dried in the same heating rate. So that's all from me. Thank you.
I'm Chiong. I will continue to present the advantage of our design from the existing design. The first advantage in our solar dryer system is we apply the regeneration system. The drying time was 27% shorter when we applying the activation reactive humidity of 80% instead of 28%. This will increasing the temperature from 60 to 70 degree. The drying time is slower, around 10%. Next, we apply the two solar collector are designed in the both sides, and the shape is regrowth collector. According to the research of Muhammad Aharu Karim in 2005, a regrowth collector is more effective than a flat plate contactor of identical design by 12%. Next, we also install the thermal detector and the humidity detector to detect the temperature and the humidity in the solar chimney tower. Finally, we also install the timer to record the time for the solar dryer system to dry the tomato. That's from me. Thank you.
Hello and Assalamualaikum. I am Muhammad Ridhwan. I'm going to explain about financial analysis. So here we go. There are 8 parts in our project, which is the first one radiation tube, second solar collector, the chamber, centrifugal blower, support, insulator, wheel and support sensor. For our product, radiation tube and chamber are using the same type, which is aluminium. For solar collector, we are getting the parts from Alibaba, which is cost 2,000 ringgit. For the fan, we are using centrifugal blower, 2 centrifugal blower, which is cost 200 ringgit. And for support, we are using stainless steel square hollow 1 mm, which is 82 ringgit. For insulator, we are using just mirror wood to avoid the heat from the inside going to the outside. And for wheel, we are using heavy duty rigid civil. And the board, we are using one set, which is Arduino Uno, humidity and temperature sensor and the screen. Next, we are going to additional costing. There are 3 main concerns here. The fabrication charges, which we will assume that the price will be 5,000 ringgit. Installation and commissioning will be 4,000 ringgit too. And the tomatoes, we assume that our product can hold around 10 kilo, which is around 50 ringgit. So the analysis is made in order to estimate the total overall cost in the product. Since the budget allocate is 50,000 ringgit, the cost needed to build a prototype for drying is less than the budget, which is around 31,000 ringgit, include the additional costing. With this amount of budget, we can build 2 prototypes and produce more dry crops in the solar drying. That's all from me. Thank you.
I'm going to talk about the conclusion of this project. The design solar dryer is active type solar dehydrator that proved efficient on experimental basis. The 1,500 gram tomatoes was dried in this dryer within 4 days each respectively, which was hygienic and safe with nutrients, means the experiment is ideal for large-scale use. Quality and color of tomatoes is also not damaged. Temperature control system prevented vegetables from burning and cooking during peak sunshine hours. Thank you.